Okay, here we are talking about a different concentration unit. We're going to be talking about molality. Is our final concentration unit we're going to determine, but in order to do that, we need to first find molarity. Okay, so we're given information here about a solution. A student dissolves 11 grams of our solute in 100 milliliters of a solvent, and the solvent has a density of 0.95 grams per mil. And we'll see why that density is needed later. So what they ask us to do is calculate the molarity of the student's solution. The molarity and the molality of the student's solution, and round our answer to two significant digits. Now, the reason why you may want to switch between molarity and molality is because that one of these concentration units is temperature independent, and that's going to be molality. So molarity is moles of solute per liters of solution. Well, you know that as a solution heats or cools, the volume of that solution can change. So that means that as the temperature of solution goes up, well, if the volume also increases, that could reduce the molarity of the solution or vice versa. Molality, when we're dealing with concentration units in reactions where temperature fluctuates, etc., molality is a good concentration unit to use because it is temperature independent. Temperature can go up of the solution, temperature of the solution can go down, but the mass of the solvent is never going to change regardless of how warm or how cold the temperature of the solution becomes. So here I have some steps for determining the molarity and then subsequently the molality. Now we'll note that this capital M represents molarity. Molarity is represented by capital M. This lowercase m here represents the concentration unit molality. So little m is molality. Okay? Alright, so step one says, first thing we need to do is find the number of moles of the solute. Find the number of moles of the solute. You can see why. Molarity, moles of solute, is here in the numerator, and it is also there for molality. So it's something that we need, right? If these are the equations we're using, we need to first find this. Okay, so how do I find the number of moles of solute? Guess what? If I go back to the passage, it tells me I have 11 grams of my solute, and it gives me the chemical formula for my solute. So because I have the mass, and I can find the molar mass, I can very easily get moles. So let's go back here and let's tackle step one, finding moles of solute. I have 11 grams of biphenyl C12H10. The molar mass of biphenyl is 154.21 grams in 1 mole. If I take 11 and I divide it by 154.21, I get 0.0713 moles. Okay, 13 moles. So I'm going to leave it there. I'm not going to round it too much. I may even add another digit there just to make sure I don't affect my answer too much. So we can move on to step two. Find molarity. Capital M is molarity. Molarity is equal to the moles of solute divided by the liters of solution. Let's go back. They give me here the volume of the solvent. So this is obviously a solid here. It's dissolved. I had 11 grams. Its melting point is fairly high. So it's a solid at room temperature. I dissolve it in 100 milliliters of this solvent. Okay, so the liters of solution that I have, I'll have a 100 milliliter solution. And I know that I have a 100 milliliter solution because of the information given here. The student notices that the volume of the solvent does not change when the biphenyl dissolves in it. So the volume is exactly the volume of the solvent that we started with, even though I added solute. Okay, so that means that the solute-solvent interactions must be fairly strong, and they're held together pretty tightly. Okay, so the moles of solute is going to be 0.07133 moles, and the total liters of solution, well, I can't put 100 because that's in milliliters. So I have to take 100 milliliters and convert it to liters, which is 0.1 liters. So 0.1 liters. So if I take that and divide it by 0.1, I get 0.7133 molar. Okay, so this is the unit of molality. The units of molality is moles per liter, and the way I would say this is I have a 0.7133 molar solution. Okay, so now that I have that, I can move to finding the molality, which is here in step 3. Well, what do I need to find molality? I need moles of solute. We have that. I need kilograms of solvent. Well, let's go back to the information. They give me the volume of the solvent, but not its mass. Well, I have a problem. How can I get the mass of the solvent? I can get the mass of the solvent because they give me the density of the solvent. So if we go back, let's write what we know about density. Density is equal to mass divided by volume. Well, I want to know the mass of the solvent. And guess what? I have the density, it's given in the problem, and I have the volume. It is 0.1 liters or 100 milliliters. Okay? So the units of the density is 0.95 grams per milliliter. So I'm going to use milliliters here, and we should be able to solve for mass. How do we solve for mass? Mass is equal to density times volume. If I rearrange this formula here by taking V, multiplying both sides by V, it cancels on this side, and I get mass is equal to density times volume. Okay, so this is the formula we're going to use. So the mass of the solvent is equal to the density of the solvent, which is 0.95 grams per milliliter, times the volume of the solvent. And the volume of the solvent it needs to be in milliliters, is 100 milliliters, and to this degree of precision. So 0.95 times 100 gives me a mass of 95 what? Milliliters cancels, it's 95 grams. Okay? They say here, if I'm going to find molality, the units of molality are moles per kilogram, just like the units of molarity are moles per liter of solution. So let's convert this to kilograms. 0.095 kilograms. So now, if we can find molality, I need moles of solute and kilograms of solvent. Let's see if we have it. We have this, and I have this as well. This is the mass of the solvent in kilograms. So, molality is equal to 0.07133 moles divided by 0.095 kilograms. And when I put this into the calculator, I get And it's going to be rounded to, they say, 2 significant digits. So my calculator answer is 0.751 molal, and my rounded answer would be 0.75 molal. That's how you would report that answer. So here's my molarity. Let's round this one as well. I'm going to round it. It's going to be 0.71 molar and 0.75 molal. So we write that here, molar, 0.75 molal.